This video covers section 11.1, composite functions and inverse functions. Objective 5, find the inverse of a function defined by an equation. We've learned how to find the inverse of a one-to-one function defined by a map, a set of ordered pairs, or a graph. And finding the inverse function would all amounted to understanding that if A, B is on the graph of the function, then B, A is on the graph of its inverse. We saw it all relied on interchanging or swapping the variables. We now find the inverse of a function defined by equation doing the same thing. Switch your variables and solve for the new function. We know that when we have functions, y is the function. Y equals the inverse. So what we're going to do is switch our variables and solve. So in order to switch your variables, step 1 says go ahead and put y back in for f of x so that we can now switch. Step 2 says in y equals f of x, interchange the variables x and y, and that means x now is a function of y. This is the inverse function defined by an equation, x equals 2y plus 5. But we like to have our functions with y equals f of x. So now we solve for y. This is where we use inverse operations. We need to know that the inverse of adding 5 is subtracting 5. The inverse of multiplication by 2 is dividing by 2. And this gives us y equals x over 2 minus 5 over 2. That is our answer. That's what we set out to find. Now we know that y is the new function, and we say f to the negative 1, or f inverse of x is 1/2 x minus 5 halves. You could verify your result for the property of inverse functions, which is if you stick a function into its inverse, you should get x. Stick an inverse into the function, you should get x. I am not going to require you to do that, but here is your function. It makes a lot of sense in terms of how do you undo multiplication by 2 and adding 5. If you try to undo multiplication by 2 and adding 5, then you would say let's subtract 5 and divide by 2, or 1/2 x minus 5 halves, which is what we found. Linear functions are easy to find the inverse of. It's when we get to rational, cube rootings, quadratics, those are a little bit harder to find the inverse. So here's a rational function. We need to do the formal step first, which is just put the y back into the problem. The step where we form the inverse is by swapping your variables. Now I've formed the inverse, and now I have to solve for y. And I'll do that by clearing the fractions, multiplying both sides by y plus 2. The y plus 2 is going, I'm left with 1 equals, and now I'll distribute this x across and write yx plus 2x. Solving for y, we have y times x equals 1 minus 2x. To solve for y, we divide both sides by x, and this says that y is equal to 1 minus 2x all over x. Last step, we have found the inverse. Y is equal to f inverse of x. The inverse function is 1 minus 2x over x. And so there's the inverse of our function. And so we circle that. Example 7, find the inverse of a cubed rooting function. We should expect to have some kind of cubing function to result for our inverse. We know that cube root and cubing are opposites of each other. So we do the first foremost step, which is getting y back into the problem. And then we form the inverse. Swap x with y. The method is called switch and solve. So now we're switching. And now we solve. Solving for y, we have to get the cube root isolated. And now we undo that cube root by cubing both sides. The cube and the cube root undo each other because they're inverses. And now we subtract 2 from both sides. And there's our inverse function. And the last step is to tell me that that's what you found. And so we have f inverse of x is equal to x plus 3 cubed minus 2. This leads me to 2 practice problems for you to try. I encourage you to press pause on your video and work these out. And come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. The linear functions, these are the easiest ones to invert because we already know how you undo multiplying by 4 and subtracting 9. You would add 9 and divide by 4, giving us 1/4 x plus 9/4. But by the switch and solve method, we first start by putting the y back into the problem. Now we do our switching. And now we do our solving. Solving for y, we would add 9 to both sides. And then we would divide by 4. That gives us 1/4 x plus 9/4. And then the finalization is to say, well, we found the inverse. It's f inverse is equal to 1/4 x plus 9/4. These ones are pretty easy for us because we have good notions of how to undo subtraction and multiplication. Letter B is a little bit harder because we're not used to manipulating these kinds. So we start with the formal process first and put the y back into the problem. Now we switch our variables to form the inverse function. We have formed the inverse function. To find it, we have to solve for y. So to do this, we clear the fractions. Multiply both sides by y minus 3. I get y is equal to y minus 3 times x. Whenever you solve for any variable, you get all of those terms that have that variable on one side and all the terms that don't on the other side. So I need to get rid of these parentheses and write yx minus 3x equals y. So getting all the y's on the same side and all the terms that don't have a y on the other side. So I'm going to add 3x to both sides. And now I'm going to subtract y from both sides. Yx minus y equals y plus, sorry, the y is gone, equals 3x. Okay, this next step is troubling for some students. How do you get that y by itself? Yx minus y. We're used to collecting like terms, but they don't really look like terms because it has the x on it. So instead we think of how would you factor out the y that's on both of those terms? Factoring out a y, you think of dividing by y there, which leaves you with x, and dividing by y there leaves you with 1 or negative 1. Now we have the number in front of y to divide by to get y by itself. We get y is equal to 3x over x minus 1. Now don't forget the last step. We have found that the inverse of f is 3x over x minus 1. And that's how you find the inverse of a function given as an equation. And this concludes the video for section 11.1, composite functions and inverse functions. Objective 5, find the inverse of a function defined by an equation.